1 second. Yeah.
Recording in progress.
Okay. Okay, clean the host. Just I am sharing the screen. So we'll discuss about this what we call asynchronous reset and synchronous reset. Okay, and what is reset? Okay, so basically this is one of the important topic. Okay, what is reset and what is this asynchronous and synchronous reset? Okay, we will discuss. Just my screen is visible now. Yes. What is reset? Okay. Anyone respond? My screen is visible now.
Yes, sir, visible.
Oh, okay. So what is reset? Okay, what is reset? Reset is nothing but what? Suppose if you want to like if you want to reset all devices to initial state, so that is nothing but we are using this reset. Okay, so we are in initial state. We want to initialize. We want to reset all the devices with initial state. We are using reset. Okay, basically to its initial position and whatever the outputs to 0. So particularly flip flop is there, so flip flop output, so we need to make as 0. We are using this reset. Okay, so resets are two types. One is active low reset and active high reset. Okay, active low reset and active high reset. Again, in active low reset there are two types are there: synchronous low reset, and synchronous asynchronous low reset. Okay, again in active high reset, synchronous high reset, synchronous asynchronous high reset. Okay, so we'll try to understand what is active low reset. Okay, so active low reset is nothing but so basically when active low reset means when this is 0, it will be in which mode? Means reset mode. Okay, when it is 1, it will be which mode? Means functional mode. Okay, so that means here when it is going from 0 to 1, okay, when it is going from 0 to 1, here we call as reset removal. Okay, when it is going from 0 to 1 we call as reset removal, and when it is going from 0 to 1 we call as what? It is going from reset mode to functional mode. In the reset mode the output of q becomes what? 0. In functional mode you will get q equal to what? D. You will get q equal to D. Okay, and after that when it is going from 1 to 0, when it is going from 1 to 0, so this is nothing but it is going from functional mode to reset mode. Okay, so when it is going from functional mode to reset mode, this q becomes what? 0. That means output, that q becomes 0. Okay, so that means what you can understand? So that means this is nothing but reset applied. So that means when it is going from 0 to 1, okay, 0 to 1, so this is nothing but we can call as reset removal. Reset removal. Okay, when it is coming from 1 to 0, okay, 1 to 0, so we call as reset applied. Reset applied. Okay, so see here. So reset removal, or we can call as reset deasserted also. Both are same. Reset removal or reset deasserted. That means when it is going from where to where? 0 to 1. Reset applied means what? It should come from 1 to 0. It should come from 1 to 0. Okay, that is nothing but reset asserted. Okay, and active high reset is nothing but what? Active high reset means so when it is 1 it is in reset mode, and when it is 0 it will be in the functional mode. Okay, so when it is going from 1 to 0, that is nothing but reset removal, and when it is going from 0 to 1, that is nothing but reset applied. Okay, reset removal and reset applied. Okay, so that means 1 to 0, when it is going from 1 to 0, this is reset removal or reset deasserted. Okay, and when it is going from 0 to 1, we call as reset applied. Okay, reset applied. Okay, so this is active high reset. Okay, so basically this is active low and active reset, active high reset. And suppose this is the circuit diagram. So if you take the circuit diagram, there are two types of resets. We are talking about active low reset. So synchronous active low reset and asynchronous active low reset. So synchronous active low reset, how we can give means we can give with 2x1 mux. We can give with the 2x1 mux. So if it is 2x1 mux, so what happens? This is what. So you know the 2x1 mux. We already seen the 2x1 mux, no? So there are two inputs
Yes.
are there. One selection line is there. So depending on the selection line, suppose s equal to 0, I0 is connected to output, no, and s equal to 1, I1 is connected to the output. Okay, so here what happens, this is a predefined word, reset n. Reset n is nothing but reset active low. So when it is 0, which is connected to D, 0 is connected, one tick binary 0. This is one tick binary 0. 0 means what? 0 is connected. Okay, if it is 1, so which is connected, D is connected. Okay, D is connected, or I can connect with an AND gate also. Okay, D and reset I can connect with AND gate also. So AND gate means suppose D and next reset n, and let us take the output is D. Okay, so if you see the AND gate, what is the truth table? 0 0 0 1 1 0 and 1 1. Okay, so here if you see, so that means if reset is reset is what, one second, here you need to take reset, here you need to take reset, here you need to take n, here you need to take D. Okay, so if reset is 0, what happens, you are getting D output as 0 only. Okay, D is nothing but 0 only. If reset is 1, what happens, you are getting 0 1, whatever this input is there, you are getting the output. Okay, so one of the disadvantages then, what is this means, there is a extra combinational circuit will be there, and we need to calculate the timing for this path also. If you take care of this static timing analysis, in the static timing analysis we are dealing with the delays and timing path. Okay, delays and a timing path. In the timing path, you need to calculate the timing path for this also. Okay, this is one of the disadvantage of synchronous active low reset. Okay, whereas asynchronous active low reset, there is no combinational circuit is required, just whatever the active low reset is there, directly you are connecting. Whatever the active low reset is there, directly you are connecting, and it is connecting through the bubble. That from that we can say that this is active low reset. Active low reset. Okay, active low reset, and this is D. Okay, there is no combination circuit. There is no combination circuit in this. Okay, so this is nothing but asynchronous. There is no extra circuitry for asynchronous reset. So that's why we can prefer this asynchronous reset. And one more reason is there, that I will tell you. Okay, next, mostly in the design or in the design part or in D flip flop, why we use active low reset? Okay, why we use active low reset? Why we not use active high reset means I will tell you. So if this is active low reset, this is what? Active low reset. Okay, active low reset means when it is going from 0 to mode 0 to 1, it will be going from where to where? Where to where? Reset mode to functional mode. Okay, it is going to reset mode to functional. In reset mode, Q equal to 0 you are getting. In functional mode you are getting Q equal to D you are getting. Okay, Q equal to D you are getting. Okay, but when it is going from 1 to 0, it is going from where to where? Functional mode to reset mode. Here Q becomes what? 0. Functional mode to reset mode, Q becomes 0. So that means what happens? So that means when it is there in reset mode, if there is no power, okay, even though there is no power, automatically it is going to which mode? Reset mode. Understood? So that means there is no power. Here there is no power. If there is no power, so if you switch off your device, so that means during no power, our design or whatever the device is there, that will be in which mode? Reset mode. That will be in reset mode. Okay, that is for what purpose? For which one? Active low reset. Active low reset. Suppose if you take for active high reset, see here, this is active high reset. Active high reset means When it is 1, this is reset mode. When it is 0, it will be functional mode. So when it is 1, it is reset mode. Q becomes 0. Functional mode means what? Q equal to D you are getting. Okay. So when it is going from 1 to 0, it will be what? It is going from reset is removed. So it is going from reset mode to functional mode. Okay. When it is going from 0 to 1, reset is applied. Okay. So that means reset is applied. So it is going into reset mode. Okay. So here so here I need some power to go from 0 to 1. Why? Because here 1 is there. Here 1 is there. So I need some power. Okay. So that means for making this into reset mode, I am using some power. Okay. So I am using that power. So that means in VLSI we need to use low power. Why we are using for this power in the reset mode? It's not required, no. So we are in order to operate this reset mode in reset mode, we are applying extra power. Okay. So we are wasting the power to make that in reset mode. Okay. So that is not required. That's why we will not prefer active high reset. We will prefer which preset? Active low reset. Why? Because even though when the power is there is no power, in the absence of power, what happens? There is no power, it will be which mode? Reset mode. So here in active high reset, what happens in active high reset? So here that means we need to apply a additional power to make into reset mode. Okay, that is that is not feasible. That is not we should not take into consideration in the VLSI. Okay, so that is about the active low reset and active high reset. Remember, basically we'll prefer active low reset only. Okay, so that means if no power is there, so it will be operated in reset mode only. Okay, no need to apply extra power in the active low reset. Okay, so we are not using active high reset. Okay, so next if you see, so synchronous reset, if you see synchronous reset, this is small program. So when I tell the very log, I will tell you, just you try to understand this. So this is synchronous reset. Synchronous reset means always is nothing but this is a keyword, forever or continuously. At the rate, this is sensitivity list. If there any change in this, that output will change. So always at the rate passage of clock. If not of reset means what? If reset equal to 0, you are forcing the output to what? 0. You are forcing the output to 0. Else means what? If reset equal to 1, it will be functional mode. That means Q is assigned to what? D. Okay. So that means if reset equal to 0, it will be which mode? Reset mode. Okay. If reset equal to 1 means what? It will be in functional mode. Okay. So now we will try to understand with waveform. Okay. So here you see. So I am talking about D flip flop. So there are like clock pulses I given, 7 clock pulses, and this is D input. Okay, this is D input. So if you see here I applied the reset. So that means initially reset is what? 0. Initially reset is 0. It is going from reset 0 to 1. So that means it is going from where to where? Reset mode to functional mode. This is functional mode. This is what? Functional mode. Okay, this is functional mode. And after that, here after some period, again this is 1. I am going to which mode? Reset mode. Okay, so here reset removed. This is nothing but reset removed and functional mode, and reset applied. Okay, reset applied. So what happens here? Synchronous output means whenever I applied the reset, okay, whenever it is going into functional mode, the output is not following D input. See here output should follow the D input. When the output is following the D input? During the passage of clock only. In this, the D is 1, the output is 1. Okay, so that means we can say that this is synchronous with the clock. Okay, so when it is changing into functional mode means when during the clock edge, during the passage of clock. Suppose here, so till here this is functional mode, you are getting whatever the value of D into Q. So till here this is functional mode only. Okay, so this is for functional mode only. Okay, after that what happens here, it is going from functional mode to reset mode. That means reset applied, you are applied the reset. When you apply the reset, what happens, immediately it is not going into reset state. Okay, it will be in the functional mode only. When it is going into reset state, here it will be functional mode only. Okay, when it is going into reset state, during this
Awesome.
passage, it is going into reset. Okay, so from this what I can say, reset, reset removal, reset removal is synchronous, reset applied is also synchronous. This is synchronous and this is also synchronous. Both are synchronous with the clock, both are synchronous with the clock. Okay, reset
Yeah.
removal and reset applied both are synchronous. Okay, so you see, so that means from this I can say that both reset removal and reset applied both are synchronous, with the active edge of clock, Okay, and next if you see asynchronous. Okay, asynchronous, so this is one some piece of code, Verilog code. Always at the rate passage of clock or neg edge of reset, you need to use in the sensitivity list, passage of clock or neg edge of reset you need to use. Okay, if not of reset, that means what, when reset equal to 0, q becomes what, q becomes, this is non-blocking operator we are using in the sequential circuit. When we discuss the Verilog, I will tell you, q becomes what, q becomes 0. Okay, else means what, if reset equal to 1, q becomes what, q becomes d, Okay, so this is one some piece of code in Verilog. Okay, so this I am trying to analyze with timing diagram. See here. So here what happens, when reset is applied. Okay, when it is going from 0 to 1, this is reset mode, and this is functional mode. This is what, functional mode. So in the function, so this is what, reset removal, so in the reset removal what happens, it is, so during this reset removal, the output is not following the input. Okay, when it is following the input, during this clock edge, the output is following the input. During this passage, the output, that means q is following what, input, q is following input. So I can say that reset removal is what, synchronous. Reset removal is synchronous with the clock. That means it is when it is there in the functional mode, when it is going from reset mode to functional mode, this is what, synchronous with the clock, Suppose here this is functional mode, till here it will follow the D input. Okay, it will follow the D input. Suppose when it is coming from 1 to 0, that is nothing but what, reset applied. Okay, it is going from functional mode to reset mode. Okay, so when it is coming from functional mode to reset mode, what happens, immediately irrespective of clock or independent of clock, immediately it will go to 0. Immediately it will, q becomes what, 0. Okay, so that means reset applied we can call as asynchronous.
Asynchronous.
Reset removal is synchronous, but reset applied is what, asynchronous.
Yes.
Okay, so now my question is, which one will follow in the design, either synchronous or asynchronous, synchronous reset or asynchronous reset. Okay, any idea, synchronous reset or asynchronous reset? Okay, so basically in the design we will follow asynchronous reset only. Why? Because suppose based on the timing also I told you, like based on the hardware also I told you, so you want more timing, you need to calculate timing for this reset also. Okay, in the static timing analysis. Okay, so this is one of the disadvantage of synchronous reset, that's why you are using for asynchronous reset. Basically suppose like if you want to reset the design, okay, sometimes by default clock is not working. Okay, so clock is not working when you are using synchronous reset. So what happens, so that is synchronous reset is what, synchronous reset is operating with the edge of the clock. Okay, if clock is not working, what happens, can you reset the device? You can't reset the device. Okay, you can't reset the device. Okay, that is the main disadvantage of this synchronous reset. Suppose like in asynchronous reset, During the functional mode, that means during reset mode to functional mode, this is synchronous only. Suppose like if you suppose clock is not working, if you want to reset the circuit, okay, here you see, so this is nothing but reset applied is independent of clock. Respective of clock, directly you can reset the circuit. So in the most of the design you will use which type of reset? Active low reset. Active low reset. Okay, that a reason I told you. And what type of reset we are using? What type of we are using? Asynchronous reset we are using. Asynchronous reset we are using. Yes.